For most of human history, we looked at the stars with wonder, but with limits. Our eyes, even aided by ground-based telescopes, were blurred by Earth's atmosphere, a constant shimmer, a veil between us and the true nature of the cosmos. We saw stars, yes. We saw galaxies, but we were missing the detail, the clarity, the deeper truth. So we dared to dream. What if we could rise above the atmosphere? What if we could place a telescope in space? A lens that orbits Earth, weightless, silent, and unobstructed, capturing the pure light of the universe as it truly is. That dream became reality in April 1990 when NASA launched the Hubble Space Telescope, a $1.5 billion marvel of engineering. But within weeks, that dream turned into a nightmare. Hubble, the most ambitious scientific instrument ever sent to space at the time, didn't work. What followed was a story of embarrassment, redemption, and one of the greatest comebacks in scientific history. This is the tale of the billion-dollar telescope that almost failed and then changed our view of the universe forever. The idea of a space telescope didn't begin in the 1980s. It was born decades earlier. In the 1940s, astronomer Lyman Spitzer first proposed the concept. A telescope launched into space, free from the turbulence of Earth's atmosphere, capable of seeing farther and clearer than any telescope on Earth. But at the time, it was science fiction. Rockets couldn't reach orbit, and the necessary technology didn't exist. That changed with the space age. As NASA matured in the 1960s and 70s, so too did the ambition to build something more than a tool, a floating observatory that could rewrite astronomy. It would be called the Hubble Space Telescope, named after Edwin Hubble, the astronomer who first proved that the universe is expanding. The goal was monumental, a telescope that could see back in time, to the earliest galaxies, the birth of stars, and perhaps even to clues about the origins of the universe itself. By the time Hubble was ready, it had become the most expensive and technologically complex scientific satellite ever built. Decades of planning, thousands of engineers and scientists, billions of dollars. One shot to get it right. On April 24, 1990, Space Shuttle Discovery roared into orbit, carrying the Hubble Space Telescope in its payload bay. In the days that followed, the telescope was deployed, its solar panels unfurled, its systems activated. At last, humanity had placed an eye in the heavens. Excitement rippled across the scientific community. Anticipation filled the air. What would Hubble reveal? And then disappointment. As Hubble returned its first images, the data stunned engineers and astronomers, but for all the wrong reasons. The images were blurry, not slightly, but profoundly. Instead of crisp views of distant stars and galaxies, Hubble returned fuzzy, distorted images. Its incredible 2.4-meter mirror had a spherical aberration, a flaw just 2 microns wide, thinner than a human hair, but devastating in its effect. The mirror had been ground to the wrong shape. After decades of effort, a billion-dollar telescope had a defective eye. The reaction was swift and brutal. Hubble became a punchline. Late-night comedians mocked it. Critics blasted NASA for incompetence. The media dubbed it the $1.5 billion blunder. In an era where confidence in spaceflight was already shaken, barely 4 years after the Challenger disaster, Hubble's failure was another blow. But this was more than a technical glitch. For scientists, it was a catastrophe. The telescope they had waited their careers to use was broken. Years of research proposals, entire academic careers, on hold or wasted. Behind closed doors, NASA engineers scrambled. They knew that the telescope itself worked. The sensors were functional. The problem was optical, correctable maybe. And so, The agency began work on what would become one of the most daring space repair missions in history. Failure was no longer an option. Hubble would be saved, or it would become a billion-dollar tombstone in orbit. The plan was audacious. NASA would launch a manned servicing mission to intercept the Hubble in orbit and install a corrective optics package, essentially a pair of glasses for a nearsighted telescope. This fix-it device was called COSTAR, the Corrective Optics Space Telescope Axial Replacement, a small suite of mirrors designed to cancel out the error in Hubble's main mirror. Alongside COSTAR, astronauts would replace other instruments, gyroscopes, and solar panels, essentially upgrading and restoring Hubble during a series of complex spacewalks. In December 1993, Space Shuttle Endeavour launched into orbit with a crew of 7. For 5 days, astronauts performed 5 high-risk EVAs, floating hundreds of kilometers above Earth, working in zero gravity to repair a telescope the size of a school bus. It was one of the most complex missions ever attempted in space, and it worked. In early 1994, Hubble opened its corrected eye to the universe. The first image came in, a star cluster, once blurry and indistinct, now appeared in crisp, razor-sharp focus. The difference was breathtaking. Astronomers wept. Engineers celebrated. The public gasped. Suddenly, Hubble wasn't a joke, it was a triumph. Over the next few years, Hubble would go on to produce the most iconic images in the history of astronomy. The pillars of creation, the deep field, the glowing remains of supernovae, and galaxies colliding in slow cosmic dances. The telescope that almost failed became the telescope that rewrote the cosmos. With its repaired vision, Hubble didn't just take pretty pictures. It made science. It measured the age of the universe, refining it to about 13.8 billion years. It discovered that the universe's expansion is accelerating, leading to the confirmation of dark energy, a mysterious force that makes up most of the cosmos. It peered into the atmospheres of exoplanets, detected the birthplaces of stars, and witnessed galaxies billions of light years away, looking back in time to the early universe. It showed us that black holes lurk at the centers of galaxies. It helped confirm the Big Bang. And perhaps most importantly, it gave us a cosmic perspective, a humbling awareness of how vast and beautiful and strange the universe truly is, all from a telescope that nearly didn't work. In the years following its repair, Hubble was serviced 4 more times by shuttle crews, each mission upgrading its cameras, extending its life, and keeping it on the cutting edge of science. With every new instrument, Hubble saw deeper. With every repair, it lasted longer. But in 2011, the Space Shuttle was retired, and with it, Hubble's direct lifeline was severed. Today, Hubble continues to function, decades beyond its original lifespan. It is aging. Its gyroscopes fail one by one. Its instruments drift, but still it sees. Every year, it sends back images that ignite wonder in scientists, in students, in ordinary people staring at the stars. Hubble's early failure could have ended its story. Instead, it became part of its legend. Because Hubble isn't just a telescope, it's a lesson in humility, in perseverance, in not giving up on a dream just because it falters at the start. The telescope that almost failed became the foundation for everything that followed, from the James Webb Space Telescope to next-generation missions probing the origin of life, to our eventual search for Earth-like worlds. Without Hubble, we would not be where we are today. We would not see what we now see. Right now, as you hear this, Hubble is out there, 547 kilometers above Earth, racing through the darkness at over 28,000 kilometers per hour. It orbits silently, steadily, its lens still pointed at infinity. It watches the stars. It watches the past. It watches us. And through it, we have seen what we could never have imagined: stellar nurseries, dying suns, ancient galaxies frozen in the light of time. We once built $1 billion eye to gaze at the cosmos, and for a moment, a brief, fragile moment, that eye blinked. But then we opened it, and what it saw changed everything.